So in this video, we're going to go through just a couple of inequality radicals. I have a bunch here. They're fairly quick to do. But again, same rules apply as in every inequalities. If you divide or multiply by a negative number, you're going to flip your inequality sign. Other than that, it really is solving exactly the same way as you would solve any regular equation, any regular radical equation. So first things first, you want to take your radical, get it by itself, right? So we're going to start by subtracting the 3. You always add or subtract before you multiply or divide. That is a common mistake I've been seeing, so please make sure you watch out for that. So we subtract the 3, then we're going to divide by the 2 to get that by itself. So we have the square root of x less than or equal to 5/2. In order to get rid of the square root, we should know that we got to square both sides. And then you're going to be left with x is less than or equal to 25/4. Okay, now here's an issue that we do need to be aware of. We have an even root and a less than that we started with. So we have an even root restriction. What that means is you're going to take the inside, you're going to take the radicand, which is x. You're going to set it greater than or equal to 0. If you had to solve it, you would. So if there was something like x plus 2, then you would get the x by itself. In this case, all this is telling me is that x has to be greater than or equal to 0 because I need a positive number to work with inside a radical. Okay, so this original answer that said x is less than or equal to 25/4, remember, less than or equal to is every number less than that. So if I can't have a negative value inside a radical, I have to keep that in mind. So I have to kind of put a cap at the end of it. And that's where this root restriction comes in. So whatever you get from your even root restriction, in this case it is 0, your final answer is going to be 0 less than or equal to x less than or equal to 25/4. That's going to be your final answer. Now there's no checking with these. You don't have to plug in the 25/4, but the check really is this even root restriction. Make sure if you have an even root and it's a less than solution, you take note, am I going to have a negative on the inside? And what would make sure that it is a valid answer? Okay. For the second one over here, root's already by itself. So all we're going to do is raise it to the 3rd power to make sure that the exponent goes away. Sorry, the radical goes away. So we drop with x plus 7 greater than or equal to 27. And we should all know how to solve this at this point, right? Subtract 7, and x is greater than or equal to 20. And that's it. I don't have an even root. It was an odd root. It was 3. I don't have to worry about any less thans because it was a greater than problem. So that is it. You don't have to do anything extra for that case. All right. Down here, we got to get rid of the 4 in front. So we're going to divide by 4 first to get that radical alone. We're going to be left with square root of x minus 2 is greater than 5. We're going to square to get rid of the square root. 5 squared is 25. So we have x minus 2 is greater than 25. And again, we know how to solve this. Add the 2, and you get x is greater than 27. Now, again, I can stop here. Even though it was an even root, I did have a square root, it's greater than. So I don't have to worry about any negatives because it's telling me every single value is going to be bigger than 27. So we're good. We don't have to worry about anything in that case. All right, our next one. Get rid of that negative 2. So here we go. We're dividing by a negative. When we divide by a negative, you're going to turn your symbol around. So x plus 4 is going to be now greater than a negative 6. From here, get your root by itself. Or get rid of your root. I'm sorry, it's already by itself. So we're going to raise it to the 3rd power. X plus 4 drops out. Now again, it's a greater than symbol. Negative 6 to the 3rd power, that's going to be negative 216. And again, we know how to solve this. We're going to subtract. So x is greater than negative 220. And again, it was an odd root to begin with, so I don't have to worry about anything with restrictions. It's only an even root restriction. It's named that for a reason. We only look at even roots. All right, so those are the first ones. The very last one. Okay, we got a couple stuff going on here. There's my root. Got to move things away. Start by adding the 6. Again, get the root alone by adding or subtracting first, and then multiplying or dividing. Okay, so from here, we're going to divide by that negative 0.25. And since we are dividing by a negative, we are going to flip the sign. So square root of x is now greater than or equal to, when you divide that, you're going to get a negative 12. We're going to square to get rid of the square root. So x is greater than or equal to 144. Now, with this case, since it started out as a less than or equal to problem, I do have to take in mind the even root restriction. It was a less than, and it is an even root. Again, you always go back to the originals. Please don't go back to something that changed in the process of manipulating it to solve. So the even root restriction, because of an even square root, and it was a less than or equal to. So you take the inside, which is x, set it greater than or equal to 0. I'm done. That's it. There's nothing I can do for that. So I now have x is greater than or equal to 0, but then also x has to be greater than or equal to 144. So everything all together, if I was to put that, is basically in the end, just x has to be greater than 0. Because any number, no matter what I choose, is going to work as long as it's not a negative. I know 144, I know that's a valid answer for there, and I can put it in. I will get an answer that works. But no matter what I put in, this x will always make the number be less than or equal to a negative 3. Okay, so just be aware with that. In this case, the first one, the even root restriction was x is greater than or equal to 0, and the answer was an x is less than or equal to solution. So that's when you put it as a combination, as the compound inequality. If they're both in the same direction, they're both greater than 0, greater than 144, just take the smaller one, because then everything has to be bigger than that single number. Okay. Hopefully this helps you out.